Hello, my name is Dimitris, and I'm Professor of Biomedical Informatics and Data Science at Yale. This video is part of a series of guest expert interviews that we're recording for a new Yale certificate program on medical software and medical AI. Our guest today is Dr. Vishisht Mehta, who is the Director of Interventional Pulmonology at the Lung Center of Nevada, Division of Comprehensive Cancer Centers, and also the Department Chair of Pulmonology at MountainView Hospital. Both of those are in Las Vegas. His fellowship trained interventional pulmonology, which specializes in the minimally invasive diagnosis and treatment of lung conditions. There's a growing interest and expertise in the application of AI in pulmonology, and he's a founder of a webpage, pulmonology.ai, which we'll put a link in the notes at the end. So part of when you reached out to me for this, thanks for doing this, part of the interest here is when we talk about AI in medicine, we tend to think about AI in the large academic centers a little bit, and I was curious to hear the experience of somebody, at a large healthcare center, but not necessarily, Boston, New Haven, New York, San Francisco, and the like. But before we go there, just tell us a little bit about you. Where did you start? How did you get here? How did you get into medicine, and how did you find AI? Or how did AI find you, I guess maybe it's a better term.
Definitely. No, thank you for having me. My absolute pleasure to be able to have this conversation. As far as my journey in medicine, I did pulmonary and critical care fellowship and had a lot of experience with lung cancer. I was at Sloan Kettering Cancer Center, and we are quaternary center for lung cancer. So that's kind of where my interest grew, and then did interventional pulmonary fellowship. So a lot of what I do is the diagnostic work for diagnosing lung cancer, biopsying lung nodules, lung masses. And as we try and understand who to do the biopsy for, who to not do a biopsy for, slowly around 2022 or so, I started to see more in the AI space to help make that decision. So for me, I found it to be very interesting and said, if this is something that's going to be a tool for me and my patients, then I need to be informed on how to use this correctly. You don't want to be using something new, using it incorrectly. It really doesn't do anybody any good. So that's kind of how AI kind of came into my life. And increasingly now, there are other applications in pulmonary medicine which have AI that have nothing to do with cancer. And I think we're going to see those grow.
So let's talk a little bit about just the initial interactions. I assume vendors came to sell things. That's usually often how this thing. So what was that experience like? What were the first tools that you saw? What did you like? What did you not like?
Yeah.
What was that initial impression, I guess?
Yeah, that's exactly what happened. We get found, and somebody reached out to me, and I kind of replied, and they were trying to sell software, and it's to do with lung nodule management tracking. It was a little bit not fully formed, so to speak. So I said, this is not something that I believe is ready for use or for prime time, but if there were any questions on trying to fine tune it or stuff like that, I said, you can always have a phone call. That's definitely not an issue. And part of it was also, I felt if I'm going to use this in my day-to-day, then it would help me have a good understanding of the back end to be able to really tell my patients that, okay, fine, we're using this information to make a decision, and we can rely on it X% based on the stuff that I knew. So that's kind of how it started initially for me. Yes.
Just to zoom in a little bit. So what struck you? Like you said, this is not ready or this has issues. Can you just talk a little bit more about that?
Yes, definitely. We know, so this was to do with lung nodule detection, and some of it was to do with estimating the risk of cancer. Mm-hmm. And we know that there are ways to do that based on, say, PET scans. There are some blood tests that can help you do it. The history counts. There are risk calculators like something called the Mayo score and the Brock calculator. And we know that those are reasonable, but none of those are perfect. So when I hear something as being better than what we have, it's always good to have healthy skepticism and then try and dig into the research, see what the validation was, and so on and so forth. And at that time, when I was having initial conversation to educate myself, I did not know, what is the difference between training set and validation set, whether something was trained with supervised learning, unsupervised learning, how does that matter or not? And I also kind of figured most physicians who are going to be using these things are not going to know. And I don't think everybody needs to know, things to that detail. We just need to know that the way it was tested, holds up ideally in a randomized clinical trial, which we consider the gold standard. So that's kind of some background on that, and that's where a little bit of skepticism came from. And this was all new, right? We get found constantly with different vendors and different circumstances saying this is new and this is good. And every technology, whether it's AI or not, whether it's drug or not, lab test or not, device or not, they all have been tested to different degrees. So we have to make sure that we keep whatever technology we allow to enter into practice to the same standard of testing and rigor.
So you started talking to these people, started giving them feedback. What was that experience like? What is it like for a doctor to talk to engineers? And I can go a whole lecture on what it's like for engineers to talk to doctors, but let's hear the opposite side.
So so when I had that conversation, I then started looking for other vendors as well proactively, just again for my own education, to talk to whoever was willing to talk to me. And I did get to speak to a few engineers. Some of the things we were already using, some things were new. I loved it. I thought it was a great conversation, and the people I was talking to are clearly very, very capable, very intelligent, and they had great domain expertise in what they were doing. And they were trying to get information, usually from the internet, or maybe speaking to a few people like me, and trying to translate that little bit of information into clinical products. So sometimes the products would be really good at what they do, but maybe the interface they were wrapped in needed some help. Maybe the product was again very good, but it was built on an incorrect assumption. So even though it will reliably give you a result, but it was trained on an incorrect assumption. So those are some of the things I was seeing when I was talking to the engineers. I think they enjoyed our discussions as well. I learned a lot from them, and I try to dig and understand, how the neural network or whatever have you was actually working and arriving to its conclusion. I think a lot of it to do, and I feel the role for somebody like me is to help at the start, because if you are able to do good research for a good product at the start, your outcome is much more successful. Because every step of the way, if you start off on the wrong foot, you have so much variance from where you need to go, then the divergence at every step just compounds, and it's just wasted effort. And those are kind of my thoughts, and that was my experience with the engine. I loved it.
So if there was a piece of advice you'd give to an engineer coming to talk to a doctor like you, what should
Yeah.
you do before they come? Was there things you wish they had known or that surprised you they didn't know or things like that?
Yeah, I think, in some cases they try to get information online. I think it's worth trying to talk to somebody like me who's in practice. And I would also tell whoever I spoke to that, I have my own perspective, but they must talk to many other people like me, and they must get as many different perspectives as they can. Because at the end of the day, I want the best product, whatever it is, so that will be the best way to do it. If they have, as if the engineers have, friends who are in med school or in biomedical engineering, talk to them, run the ideas by them. If there is a university which has engineering school and also med school, there's again great places to have synergy. So I think collaboration actively is something that I would feel makes a lot of sense. And I know that there's a lot of physicians like me. We don't know if it's a lot. I think there's few at least who also love that kind of interaction. And a lot of the stuff that I did and still do, it's all on my my free time. I just do it out of interest. So I think there's a lot of interested people on both sides, and it makes sense working together.
Okay, that's interesting. Yeah, it's almost a cross-cultural experience when I take students sometimes when they do projects into the medical school, and first half hour is they have no idea where they are, what's going on, what the vocabulary gets used, but after a while it gets there. So okay, so we'll talk a little bit about your involvement here. Where do you see things going, right? So your experience was 2 years ago. So let's say we started 2 years ago. Let's say we talk again in 5 years' time. What do you think you're going to be telling?
Yeah, I think it depends on, where it starts. I'll give an example. Right now, if you were to get a complete blood count to look for just hemoglobin, which is how much um, red cells we have and the oxygen carrying capacity of the blood, and we look for infection cells and a bunch of other stuff, all of that is automated. When I did med school, we had to do our own small blood sample, check it, count it, and tabulate those cells. And that's how we learned. But for practical purpose, it's all automated, but that's not how we started. So I think where AI will start with is in two places. One is flagging and prioritizing highly abnormal results. And the other one is identifying highly normal results. So those are the easy ones, right? If I see a patient's X-ray, for example, that has huge amount of lung collapse or very large amount of fluid, easy to flag those. AI is pretty good at reading normals. I'm not saying we can read a normal chest X-ray immediately and we may not miss something, we can. But most of where our brain power, intellectual capacity, efforts are deployed are in the middle, where it's not, very clearly on one side. And I think AI getting there is going to take a lot more time. We're already seeing there's a good amount of literature showing AI helps, raise the floor for everyone. So if you have novices plus AI, they tend to approximate the performance of intermediates, and intermediate performers plus AI can help to approximate the performance of experts. So these are a couple of places I see it going. Also, if you look in the lung nodule space, which is spots on the lung, concern for cancer, initially AI has been good at detecting them, then also tracking them over time, and then trying to estimate the risk of cancer. Maybe we'll even be able to say what kind of cancer it is. And there's a big gap between detecting, then tracking, then estimating the risk, and then trying to subclassify that. Because as far as we know right now, we can sometimes get the answer from blood, but it's almost always the actual tissue. So I would be very interested to see, and I will follow closely how the progression goes. And again, all of this is still identification, as far as I see. This is not yet intelligence, you know. So there's many steps to go, but the progress has been rapid so far.
Okay. And I know we talked before we started, how does this whole affect the patient now? So when the doctor is making a decision, you tell the patient, well, I looked at your images and we're fine. Now you're using AI. So how do you communicate to the patient? Who takes liabilities? Those are interesting challenges now as we bring a third party into the discussion, right? It's not you, it's your tool.
Yeah. Great question. I don't think we really know right now. So, for example, I have patients who go to different imaging centers, and some of them are using AI for nodule detection. And I tell them exactly what I see. Almost always, I'm showing my patients the images. And in the image section, they also have the AI report. So I pull it up just like I pull up the images and I tell them, this is what it is, this is the AI, this is what it found. And the radiologist also will be commenting, usually saying, these were automated nodules and that stuff, and it was detected, and these are how many, and this is my interpretation of what they found. And that stuff goes on the report. So I think the first thing we can do is just communicate and convey to the patient what we are seeing. The other part, as you say, is what is now considered, say, like standard of care. So even in my day-to-day, right, there's one facility that's using this and the others are not. Is one of them now elevated the standard of care? Are the others at the standard of care and this one that's using the technology is above the standard of care? I don't know. I don't think, I'm the medical legal expert by any stretch to be able to give that determination. I guess at some level, maybe there will be regulation to smoothen this stuff out and to be able to say, okay, here are where the minimums are perhaps, or the minimums are usual care, and then this is considered to be above that. Um, in terms of other directions, we always look to multi-society guidelines. And there are some guidelines on this stuff right now. A lot of that is coming from the radiologic societies, some that I see from the cardiology societies, nothing in a big way from at least US-based pulmonary societies. There is literature that they publish, of course. So I'm hopeful that there will be an opinion from some of the societies one way or the other. Maybe all it says is we are not ready yet for daily primetime use of AI in nodule management. Maybe it says, hey, we can say that AI is useful to detect this and identify, but not really to judge the risk of cancer. I don't know, but I think we will start to see those things kind of filter out. Liability is then a whole other thing. If the AI gets something right and the human gets something wrong, what if the AI gets something wrong, the human gets something right? Do we go with the AI? Do we go with the radiologist? Who's going to be liable? Is it the company that made the software? Is it the people who developed the technology? Is it the person who's using it at the end? I would say, there's definitely some responsibility for whoever's using it at the end. But then how do they know that the AI from vendor ABC is better than XYZ? I mean, can we really even say something like that? It's I think too complicated, at least for this stage, to be able to say stuff definitively and with authority.
Just actually as an aside, as I'm listening to you talk, so there are people like you who are really curious and want to know more, but this thing comes into a practice. There are a number of doctors there working with it. The technology is introduced. What do you feel the level, what do these people need to be taught when the tool is presented, or are they even taught? Do they just get a report all of a sudden?
Outstanding question. You're right. There is different levels of interest in the AI tools. I think how much someone needs to be taught. There's two parts to it. One is, do we trust the validation? Meaning, if say paper on AI tool is published in the New England Journal of Medicine, do we then say, okay, fine, there's a stamp of authority, for example, from the New England Journal of Medicine, for which I have no affiliation. And do we say that, okay, this is the best journal, they have approved this, they have published it, it has met the rigor for this journal, then I can believe whatever the results are. I think that's part one, which is trust. And part two is knowledge of how to actually make sense of it. Because even with AI generated results, there's noise. It's not necessarily binary, and some of the results are gradated. So if there's lung cancer risk that's 50% versus 60% versus 70%, is the 70% more meaningful than the 50% risk? Did the software take into account the patients had a history of cancer? If you have a history of cancer, then to me, your 50% risk is as important, perhaps, than someone who has no cancer, but the software is saying there's a 70% cancer risk. Those things kind of change. So I think that is two parts in terms of what education we impart. And then the other thing is, how do you impart the education? Are we going to be required to do CME activities in AI? Do we need to know when I'm seeing my patients, do I need to know what kind of validation there was or there was not? I think part of the answer to that, maybe a little bit circular, is to encourage physicians and engineers to collaborate as much as possible and provide platforms to do it. So we know that there's been input from the ground up by the people who are going to use this at the end of the day, which kind of drives my interest as well. But we could go on for hours trying to figure out what's the best way to convey education. I don't know I have the best answer right now.
And physicians have so much free time that to tell them now you have to take a lot of time to learn about all this stuff. it's going to go well. I guess the other question I was curious as I heard you talk, you said you present your results to your patient and you said, well, this was the AI report. How do patients react? Do they get excited? Do they get scared? Do they believe it more? Do they fear it more? Like, is it everywhere? Is it a little bit of everything? What have you seen?
Yeah, I think it's a little bit of everything. I don't think there's any excitement or fear. I think they just kind of go like, okay, I think it's interesting. And they say that it's interesting and unexpected, but it just means sometimes we have to reconcile, what the software sees and what we see, and we have to kind of make sense of it because, again, I think it's more believable, or the results of identification and detection are more apparent because it tends to be somewhat binary. If the AI says, I see, or not I, but the software sees a nodule on image, whatever, series, whatever. And then you can look at it. It's either there or it's not there. And the ones that I'm encountering, they also put a screenshot or just a small piece, a square with the nodule in the center. So you can tell whether it's there or not. And then you can scroll through it and see if it's really a nodule, or sometimes it's calling blood vessels and saying this is really a blood vessel. So at least for that part, with the patients, in my practice, I can show them the pictures so we can establish whether we believe it or not right away. If it comes to saying to a patient, I think your lung cancer risk is 90% based on the AI, it kind of will matter what the next step is. If the next step is we're still going to do usual care to confirm this, no problem, because we're still doing usual care. And this is not where we are, but maybe it comes in the future if usual care changes or we deviate from usual care based on this. I think that's a whole other issue and question. So patients' reactions will probably depend on a lot of that. Patients still kind of sometimes complain about EMRs over paper charts. So AI is a huge other leap from there, but it's fairly variable.
Yeah, in experience of using AI in other domains, the usual report I've heard is when the AI gives good news, nobody complains. When the AI gives you bad news, then you want to know a lot more, right? And I'm sure that's true for all medicine and for all of that. Let me change topics a little bit. The other thing that you had mentioned to me when we were talking before. So, okay, so this technology exists, but there's a challenge in getting this technology into the healthcare provider systems. At the academic hospital level, it's one level challenge. In the practice, like where you are, is a difference. What are you seeing? What are the challenges? How are things evolving?
No, great question. So if you go to a conference, so I was at American Thoracic Society earlier this year, and at CHEST, which are the two larger pulmonary conferences. CHEST was last year. There's so many different vendors, so many different shops. So I spend a lot of my time just walking around, trying to get to talk to everybody, get their literature, learn about them. And even I have to ask myself if everything can detect lung nodule. How do I know which one is better? Sometimes there's just no way to know. So can I say which one is better? Say we do establish which one is better. Are we going to make recommendations on purchase just based on that? So say think of it just same like medicines, right? There's a medication that gives you 1% benefit at 10 times the cost. Is that the one you go with? Maybe in a cost agnostic situation, which would be nice to have, but reality is not. And there's no good way to kind of answer that. So I think one issue is there's many different vendors, many different platforms saying the same thing, and how do you pick which one you pick is a very difficult situation. The other thing to think about is there going to be consolidation in the market? I'm not a business person, but my 2 cents, yes, I think there is. Even in the time that I've been looking into this, which is not all that long, just a couple of years, there's already been consolidation and some companies have merged, and that's something that we're already seeing. I think that will pick up. Then the other thing we have to think of is Do we go by pricing strategies, right? Is it going to be per use? You get billed per use? Do you get a bill per success? So if you have AI running on 100 chest x-rays a day, you get a bill for 100 chest x-rays? Do you get a bill only if it finds something in maybe 10 of them? How is it going to be priced? Is it going to be flat fee? Is it what are the data security implications going to be for stuff like this? Is data security going to be the deciding factor? Is it going to be pricing? Is it going to be performance? I believe there is one paper from the Netherlands, great set of researchers from there, and they have compared chest X-ray AIs amongst each other, and they have a lot of trust, placed in them from the vendors who gave them the software to do those comparisons. That is an ideal situation, right? Where you have the same data set and that is run through multiple different algorithms, and then we see what the performance is. But what about next year, right? If one algorithm is a version 2.0 and everyone else is still on 1.0, do we have to ask ourselves the question again? One of the things I get asked is, okay, fine, if we sign up with, algorithm ABC, then next year does it get updated? What about the year after that? Do we have to go through validation again? We just don't know. So I think right now there's just more questions than answers. In most cases, because this is software, there is not as much hardware commitment. There is still sometimes, but not as much. So it's not like you have this big piece of machinery taking up a lot of space that now you don't know what to do with, or somebody has to buy it. You can, you just end your subscription, presumably, or have some sort of out clause, and then kind of go from there. Are you going to try and go through a marketplace or a platform versus single vendor? Those are other kind of discussions we can have.
Mm-hmm. So let me throw a question at you here. So you guys contract with a vendor, you bring in a new tool into the practice. What are the first steps you do? Do you start using it on a trial basis for a while and watch it? Like, how do you build trust over time?
Yeah, it just depends. So every vendor is different. So my personal situation is a little bit unique. So I'm part of, as you said, Comprehensive Cancer Center. That's my practice. I work at MountainView Hospital as well, but the hospital itself is a separate entity. And then all these different other imaging centers that I interact with as an outsider, and then I go to at least one other hospital as well. So I have many badges, many logons. And they all function differently. So even the vendors function differently. Some will say, okay, for a month, you can do it on a trial basis. For a month, you can do it maybe as a demo, or it's a try if you commit to buy, or we start off immediately with a purchase. So usually, if I have a conversation, first we have to talk to our IT folks. We have to talk to our radiology folks, because we have to make sure we can use our hardware to give us meaningful information, which the algorithm can then use to get its output. That's just the technical portion. Then you have regulatory, you have infrastructure. Is the software going to be running on our premises or our hardware? Is it going to be running in the cloud? How do we send the stuff? Do we anonymize? How do you anonymize? So on and so forth. So even to get to the point of doing a demo, there is so much stuff that happens first. Then you can do your demo, and then you kind of get a sense of, am I getting information that I can rely on? And then we have to remember this stuff costs money, right? So how is any enterprise in any situation or circumstance going to pay for it? There's a couple of ways I look at it, which is an offensive deployment or defensive deployment, just terms that I came up with. In terms of offensive, that means you have billing codes that we can use to assign to the work done by using the software. So every use or every successful use, there's revenue to offset the cost. And the other one from a defensive side is an argument being made that if you have AI running in the background, that will help escalate or help rather reduce the amount of missed results. or if you are able to flag urgent results, that is valuable because that's speeding up the care of the sicker patients. And that, of course, is better care and efficient at the same time. So a lot of these different considerations go on constantly, and they may change, and they may change quicker. They change in most circumstances in medicine, but here the speed of everything is just quite remarkable.
Mhm. You touched on this last topic as we went along, but let me sort of bring it back here. So obviously, you mentioned a number of concerns you had as you went through. Is there anything else in that space? Is there anything else that you worry about as you see this technology? What do we need to worry about? There is a sort of the happy path, right? This technology is going to make us better and everything's great. But then there is the, okay, what could go wrong here? What do we need to worry about? So I'd just like to hear some of your thoughts there.
For sure. So, one thing that I kind of think about, again, if I were to use the lung nodule space as example, a lot of it comes down to, say, training data and then the deployment. So if we have lung nodule software that looks for lung cancer risk, and say it's trained in India, a lot of tuberculosis in India, a lot of infectious causes for lung nodules in India, can I use that same software in the same form in the US? And even in the US, things are different. Midwest has a lot of histoplasma, which is fungus causes lung nodules, which are not cancer. In my area in the Southwest, we have valley fever, causes lung nodules, and that's not cancer. And we see this happen constantly. So can one AI in different deployments function at the same level of accuracy for identifying benign, separating it from cancer? I don't know, because if it was trained in one place, how well can it work in the other place? Maybe it's too complex a consideration. Maybe I'm not considering it enough. We just don't know that. And I've had some conversations asking the engineers, do the algorithms, when the radiologists agree or disagree, do they track that? Are they continuously being supervised and learning from that? So perhaps you have a parent algorithm that was made wherever and then deployed in US Southwest, US Midwest, Asia. Will those algorithms start to get better in their local areas for those local pathologies, but be not as good for the other two things? This is really
just to stop you there. The FDA is trying to figure that out too. Like, how do you clear software that would be updated without the review? That's a big emerging challenge in this space. And it's just early days. Right now, as far as I know, everything is locked. Nothing is changing yet. Keep going.
Yeah, all I was going to say, it's almost like natural selection. This is like evolution, right? And you can also take an example from physicians. So I did some of my training in the Midwest, fellowships were in East Coast, and now I'm practicing over here. So I have seen different kinds of nodules be benign in different locations for different reasons. So I have had to retrain and reorient myself. My med school was in India. So I've been in all three of these places. And I can tell you firsthand, you have to recalibrate what you consider as you practice. You have to practice locally because prevalences are all local. So maybe that's something that we'll see. I think that's very interesting. I don't know what the answer is. Of course, other concerns always data security. We are recording this a few days after the CrowdStrike global issue. So that can happen. And maybe there's no security concern. Maybe the software doesn't work. Maybe we are used to relying on information from software and the website is down, or somebody did something, or random stuff happens. How do we defend against that? What happens to the skills of trainees? And if you train in an environment with AI overreads or AI pre-reads, does that change how you learned? Can you function then without the AI? But at the same time, if future is going to be some amount of AI support, whether in the background or bringing urgent results to the foreground, and you don't train in that environment, are you then at a handicap, down the road? It's like, does everybody need to learn how to drive stick shift? We are all, already on automatics. I don't know. In pulmonary, at least, that's not as much of a concern right now. Maybe it will be. How do then again, how do administrators judge what software and vendors we want? We spoke about doctors, right? But we can have inputs. We don't really, in most circumstances or in any, control the purse strings. What is it important to the administrators or the C-suite or whoever the decision maker is, whatever the process is? Maybe it's a committee. And how does everybody have the same amount of education or sufficient education to make a decision that everyone is comfortable with? I don't know. I don't think we know that yet.
Yeah,
So,
but at least we're living in interesting times. It's sort of a
most certainly.
big change, and hopefully things will improve. Vishisht, was there anything else you wanted to say before we close? Thanks for taking the time. My end.
No, it's my pleasure. Thank you for talking to me. I always enjoy these conversations, and if there is the one thing I would say to whoever listening, if you're not in medicine or if you're in engineering, just as an easy example, talk to your colleagues in medicine, and to the medical people, I will say, talk to your colleagues who are coming up with this stuff. We can only get better with the communication and crosstalk, because ultimately we're working for our patients. So that's all I got. Thank you.
Thank you for taking the time. Bye.